Now it's necessary to contour the proximal aspects of the sidebars so that the surfaces are parallel. Take the proximal section. Remember, this is parallel to this now. When you put the offset, we want these two surfaces to be square to each other, which means that they are both perpendicular to the base of support here. So we use a T-square, and it tells you which way you need to contour. And probably the most important thing about contouring, other than doing it very slowly, is think before you do it. That's not smart. See? Now we need to make sure we haven't messed up the alignment. Our offset here is supposed to be 2.6. So offset here's 1 centimeter. So read 1.6 in here. 1.6. So now okay, you want these dimensions to be equal. And the first rivet you put in, I'm going to put in one side and tweak the other side just to make sure everything is exactly right. You always put in the rivets that correspond with the proximal or distal calf band circumference measurements, the one that's larger. So in this case, and you can see this from looking at the schema, the circumference of the distal one is larger. So I'm going to put in the distal rivets first. So I'm going to start out with one rivet on the medial side here. Begin riveting using a number 28 Monel rivet. It takes a number 28 twist drill or a 5/32 drill. The rule regarding drill or rivets and riveting is if the rivet is harder than the material being riveted, it doesn't have to be countersunk. If it is the same density or softer, it does have to be countersunk. So since we're putting a moly steel rivet into aluminum, it doesn't have to be riveted. So we've got this one drilled. Sometimes it's hard to cut off Monel, particularly if you don't have a good grip or aren't that strong. And so you can take the snips and pinch off an edge like so. And with that done, it becomes easier then to take off the whole rivet. So we get the head to mushroom. Now nice and smooth. Alignment, and everything is right. This should be perfectly square as well. See that? So now, it's one of the handiest things you can use anytime you need to make repeated measurements. So I've already set this for roughly half the width of the sidebar. And that's going to tell me where to put that hole, and do the same thing here. And it tells me where to put the hole in this piece. You can see the two holes line up, and they were not drilled at the same time. They were drilled separately. So now we want to make sure our alignment's still good. Looking across here, these two should be parallel. These should be parallel. And our offset here should be 2.6 centimeters. And it's 2.6 centimeters. So now we're going to determine the tilt of the band. Start out with it at 90 degrees. And this movement can cause a little bit of change in the alignment, so just keep a close eye on it. So we get this square. So make sure that the edges are both square. So what we want to do now is take the difference in the two circumferences, which were 36.2 and 37.6. So that's typically, if there is more than a centimeter's difference, it's required that you make a custom shaped calf band. I'm not going to do this because I want to show you the way to do it, that you're going to be doing it with patients. The reason I say that is that patients who need this sort of orthosis typically have atrophied calf muscles, and so you don't see a lot of difference in the circumference between the proximal and distal measurements. The one place you will see it, which is the only times I've ever had to do this and make a custom band, maybe twice in 40-something years, was on patients with Duchenne's muscular dystrophy, where they have hypertrophy of the muscles. But you should not be expecting to have to make a custom band. So what we do is look at the edge here, and the difference we said was 1.4 centimeters. Divide that by 4 and it gives you 3.5 centimeters. You want to tilt the band until the amount showing here is 3.5 centimeters or millimeters. That's 3. Just for hair there. That's 3.5. see the tilt that's here. So this distance from here, this surface to that point, is 3.5 millimeters. Now we can drill the other holes here. Mark my midpoint. And distance from the edge is going to give me this point right here. Which I'm going to center punch. Same thing here. I'm just making this a little bit larger so that hopefully we won't get the drift we had before.
Bugger, aren't they?
Yeah, and there are some number 30s over there, so I would hardly recommend that students use the number 30 instead of the 28s.